Hello, this video will introduce a Wi-Fi-based key generation demonstration. The work was carried out at the Advanced Networks Research Group, University of Liverpool. This demo uses WOP boards as the test beds, which are connected to a PC via an Ethernet switch. Two WOP boards serve as a pair of key generation parties, namely Alice and Bob. The graphic user interface and signal processing are programmed using Python. The WOP boards are controlled and accessed by the WOP 802.11 Reference Design Experiments Framework. The graphic user interface is organized into different panels. The Setup panel configures the Wi-Fi parameters for the WOP boards. The Control panel can trigger different key generation steps. The Illustration panel shows the channel sampling that is performed between AP and station by using the existing Wi-Fi packets, namely the data and the ACK packets. The Waveform panel presents the RSSI of AP and station. Finally, the Results panel will include the statistical results of keys, the generated binary keys in the format of two-dimension barcode, and the randomness test results. Key generation usually includes 4 steps, namely channel probing, quantization, information reconciliation, and privacy amplification. Alice and Bob first carry out channel probing, which involves bidirectional measurements. They then convert the analog measurements into digital binaries. There will probably be mismatch between keys at Alice and Bob. Hence, information reconciliation has to be adopted to correct the mismatch. Alice and Bob will then obtain the same keys. Finally, privacy amplification is employed to remove the information leakage. We will introduce each step in detail. In this Wi-Fi-based key generation demonstration, channel probing is carried out using existing packets, namely data and ACK packets. The time delay between data and ACK packets is 60 microseconds, which is very small. The sampling interval is configured as 0.35 seconds. Click Channel Probing will start the channel probing process. Channel sampling will be carried out based on the above Wi-Fi setup. The Wi-Fi data and ACK packets are used for the bidirectional sampling. The RSSI is measured at both AP and station. The sampling delay between the AP and ACK packets is 60 microseconds. A high correlation between the measurements can thus be obtained. Channel sampling is completed when the sampling length is reached. Because WOP boards support the commercial Wi-Fi, they receive all the Wi-Fi signal in the air. We thus have to first eliminate irrelevant Wi-Fi packets based on the device MAC address. Secondly, there may be packet loss during transmission, and we should only keep packets both received by AP and station successfully. We implemented an additional step, packet match, to make AP and station have paired packets. After we click packet match, we can notice that the RSSI records at both AP and station are reduced. The next step is quantization, which converts analog channel measurements to digital binaries. This demo used mean value-based quantization as an example. AP and station will individually calculate the mean values of their RSSI as thresholds. Each device will then carry out the quantization independently. When the RSSI is above mean value, it is converted as 1. When it is below the mean value, it is converted as a 0. We use a two-dimension barcode to illustrate the generated keys, with black and white squares denoting 1 and 0 respectively. The randomness of the generated keys is evaluated by the NRST randomness test. Because of the asynchronous sampling, interference, and noise, there will be mismatch between the keys generated at AP and station. This barcode shows the difference between the keys at AP and station. An example is shown here, where AP and station generate 1 and 0 respectively, even their RSSI is very close. Therefore, information reconciliation is adopted to make Alice and Bob agree on the same keys. This demo employs BCH-based secure sketch as an example. The key disagreement rate in this example is 0.153, which is smaller than the correction capacity of BCH. Therefore, the mismatch can be corrected. Finally, privacy amplification is used to remove the information leakage during the previous steps. This is done by using hash functions. AP and station will then get the same secure key. The key generation process is successfully completed. Thank you for watching this video. Please refer to our paper for the technical details. If you need any further information, please do not hesitate to contact us.